Sample problem 3.8. Determine the empirical formula of a compound that is 30.45% nitrogen and 69.55% oxygen. So it's an empirical formula problem. And here's how we're approaching this. The empirical formula is going to be some sort of formula that has nitrogen in it. But we don't know how many nitrogens, 1, 2, 3. And it has some number of oxygens in it, but again, we don't know how many. The empirical formula is the smallest whole number ratio of atoms of each element that are possible in the compound. So for example, N2O or NO2, those would be empirical formulas. Those ratios, 2 to 1, or in the case of nitrogen dioxide, 1 to 2, those ratios are about as small as you can get. You cannot make those ratios smaller and still be whole numbers. So we're trying to find an empirical formula, something like this or something like this, okay? Here's an example of something that would not be an empirical formula. So the ratio here of 2 to 4 is not the lowest possible ratio. We could divide each of these two numbers by 2 and get 1 to 2. So if you can reduce it by anything, then it's not the empirical formula. Okay? So let's take a look here. We're trying to find the empirical formula given this problem. Now, percentages are commonly given as the amounts of each element in these types of problems. So if you're given percentages, so we have 30.45% nitrogen and 69.55% oxygen, this is perhaps the thing to try. These two percentages should add up to 100%, and they do. So let's do the following. Let's assume that we have 100 grams of the compound. If you have 100 grams of the compound and 30.45% of the compound is nitrogen, that means you've got 30.45 grams of nitrogen. Likewise, if you have 100 grams of the compound and 69.55% of that is oxygen, you could say that you have 69.55 grams of oxygen. So now all we need to do is look up in the periodic table these two elements, look up their atomic masses or molar masses, and there they are. Nitrogen weighs 14.01 grams per mole, oxygen weighs 16.00 grams per mole. So I'm going to write it this way. 1 mole of nitrogen is 14.01 grams of nitrogen. That's the molar mass. And same thing for oxygen. 1 mole of oxygen is 16 grams of oxygen. Okay? So we will eliminate the grams of nitrogen and the grams of oxygen, and that will then give us moles of each of those two elements. Okay, so 30.45 divided by 14.01 is 2.173 moles. That's the nitrogen. And then 69.55 divided by 16.00, 4.347. Okay, so those are the moles of each element. If you take a look at those two numbers, they're not whole numbers. We want to make them whole numbers. When we do empirical formulas, x and y need to be whole numbers. So here's what we're going to do. To make them whole numbers, we're going to note that the nitrogen is smaller. I'll rewrite the numbers down here where we can see them a little bit better. There's fewer moles of nitrogen than there are of oxygen. So what we'll do is we'll divide each of these by the smaller of the two. Now, if there were 3 elements, we would divide it by the smallest of the 3. So we're going to divide them all by, or both of them, by 2.173. And if you do that, of course, this is going to give you 1, which is just telling you 1 mole of nitrogen for 1 mole of nitrogen. In other words, there's the same amount of nitrogen in the compound as there is nitrogen, which is obvious, right? Now, but what do you get for the oxygen? The oxygen, when you do this ratio, you get something very, very close to 2. So that means there's 2 moles of oxygen for every mole of nitrogen. It's a 2-to-1 ratio. So guess what? 2-to-1 ratio, right? So if you have 1 nitrogen and 2 oxygens, that would be a 2-to-1 ratio. So there's your empirical formula. Now, in fact, that may not be the actual chemical formula. The molecular formula could be different. Here's a possibility. The molecular formula could be NO2, but it could also be N2O4, but we don't know, right? You can't tell from that piece of information that we have right there what the molecular formula is, but you can determine the empirical formula, which is what we were asked to do. And there you go. Empirical formula given these amounts. So assume 100 grams of the compound. That allows you to use the percentages as grams, divide by the molar mass of each element. That'll give you the moles. Divide by the smaller or smallest if there's more than 2 elements, and then that will give you whole numbers.